Hello everyone, myself B. Chanakya and I am from ECE 3A and today I am going to tell about AC bridge. In that there are two types, Maxwell bridge, A bridge. Coming to Maxwell's induction bridge. In the Maxwell's inductance bridge, there are two pure resistance used for balance relations, but on other side or arms the two known impedance are used. The known impedance and the resistance make the unknown impedances. As Z1 and Z2, such a network is known as Maxwell's AC bridge. A Maxwell bridge is a modification to a Wheatstone bridge used to measure an unknown inductance, usually of low Q value, in terms of calibrated resistance and inductance or resistance and capacitance. When the calibrated components are a parallel resistor and capacitor, the bridge is known as Maxwell-Wien bridge. It is named for James C. Maxwell, who first described it in 1873. It uses the principle that the positive phase angle of an inductive impedance can be compensated by the negative phase angle of a capacitive impedance. When put in the opposite arm and the circuit is at resonance, that is, no potential difference across the detector, an AC voltmeter or emitter, and hence no current flowing through it. The unknown inductance then becomes known in terms of this capacitance. With reference to the picture, in a typical application, R1 and R4 are known fixed entities, and R2 and C2 are known variable entities. R2 and C2 are adjusted until the bridge is balanced. R3 and L3 can then be calculated based on the values of the other components. R3 is equals to R1 into R4 by R2. That is, L3 is equals to R1 into R4 into C2. Before those limits are approached, the ESR of the capacitor will likely have significant effect and have to be explicitly modulated. Now, for ferromagnetic core inductors, there are additional constraints. There is a minimum magnetization current required to magnetize the core of an inductor. So, the current in the inductor branches of the circuit must exceed the minimum but must not be so great as to saturate the core of either inductor. The additional complexity of using a Maxwell-Wien bridge over simpler bridge is warranted in circumstances where either the mutual inductance between the load and the tone bridge entities or stray electromagnetic interference distorts the measurement results. The capacitive reactance in the bridge will exactly oppose the inductive reactance of the load when the bridge is balanced, allowing the load's resistance and reactance to be reliability determined. Rx is equals to R2 into R3 by R1. Lx is equals to R3 into L2 by R1. R2 plus j omega L2 into R3, that is equals to Rx plus j omega L jwl x into R1. This is the phasor diagram. And the advantages of Maxwell's bridge. The measurement is independent of frequency. The bridge yields simple expression for inductance and resistance. It can measure inductance from 1H to 1000H with plus or minus 2% error. And the applications are, this bridge is used to determine the self inductance of the circuit. This is used to overcome the drawback of Maxwell's bridge. This bridge circuit is used to measure the high quality factor in circuit. Thus, this is all about an overview of Hayes bridge. The quality factor can be measured by using Maxwell's as well as Hayes bridge, but Maxwell's is used to calculate medium quality factor, whereas the Hayes is used to calculate high quality factor. So, to overcome Maxwell's limitation, this bridge circuit is used. Here is a question for you. What is the difference between Maxwell's and Hayes bridge? And coming to Hayes bridge, it is also a modification of the Maxwell's bridge and is particularly useful if the phase angle of the inductive impedance is large. In this case, a comparatively smaller series resistance R1 is used instead of a parallel resistance, which has to be of a very large value. Hayes bridge is used to determine the inductance of an inductor with a high quality factor. Maxwell's bridge is only appropriate for measuring the values for inductors with a medium quality factor. Thus, the bridge is the advanced form of Maxwell's bridge. One of the arms of a Hayes bridge has an accurately characterized capacitor used to balance the unknown inductance value. The other arms contains resistors. The advantages of Hayes bridge are, this bridge is used for the unknown inductance to provide a simple expression. It is appropriate for the coil that has a high quality factor than the 10 ohms for a quality factor. The bridge provides a simple equation. It uses a small resistance value to determine the quality factor. And now coming to the disadvantages. The disadvantages of Hayes bridge are, it is not applicable for the measurement of the coil which has less than 10 ohms quality factor. The balanced equation of the bridge depends on operating frequency and thus the frequency change will influence the measurement. The quality factor is used to determine the main relationship between the energy which is stored and dissipated within the circuit. And now coming to the applications of Hayes bridge. The bridge is used to determine the self-inductance of the circuit. This is used to overcome the drawback of Maxwell's bridge. This bridge circuit is used to measure the quality factor in the circuit. The connections of the Hayes bridge can be done by connecting the capacitor and the resistor in series with each other, so that the voltage drop across the resistance and capacitance will be changed in Maxwell's bridge. The connection of the resistance and capacitance can be done parallel, therefore the magnitude of a voltage supply throughout the resistor and capacitor will be the same. And now coming to the constructions of Hayes bridge. The construction of Hayes bridge is shown below in the following circuit. L1 inductor is unknown and it is arranged with resistance R1 in between AB arm. The comparison of this inductor can be done with the capacitor C4, which is connected with R4 resistance in the CD arm. Similarly, the remaining resistance like R2 and R3 are connected in the arms AD and BC. To make the bridges in a balanced condition, both the R4 resistance and C4 capacitor are adjusted. Once the circuit is in a balanced condition, then there is no flow of current throughout the detector. Here the detector is placed in between B and D. The potential drop across the AD and CD arm is equivalent. In the same way, the potential drop across the AB and BC arm is equivalent. And now coming to the Hayes bridge theory. In the above circuit, inductor L1 known, determining the precious value of a variable capacitance. Sometimes a fixed value capacitor will be installed. More than one resistor will be made variable. It cannot be used for the measurement of high Q values. It is also unsalted for the coils with low Q value, less than 1 because of balance convergence problem. Its uses is limited to be the measurement of low Q values from 1 to 10. Q is equals to omega L by R. The frequency of the AC current used to access the unknown inductor should match the frequency of the circuit the inductor will be used in the impedance, and therefore the assigned inductance of the component varies with frequency. For ideal inductors, the relationship is linear, so that the inductance value at an arbitrary frequency can be calculated from the inductance value measured at some difference frequency. Unfortunately, for real components, this relationship is not linear, and using a derived or calculated value in place of a measured one can lead to serious inaccuracies. A practical issue is construction of the bridge is mutual inductance. Two inductors in propinquity will give rise to mutual induction. In propinquity will give rise to mutual induction when the magnetic field of one intersects the coil of the other. It will reinforce the magnetic field in that other coil, and vice versa, distorting the inductance of both coils. To minimize mutual inductance, orient the inductors with their axes perpendicular to each other and separate them as far as is practical. Similarly, the nearby presence of electric motors, chokes and transformers like that in the power supply for the bridge may induce mutual inductance in the current circuit component. So locate the circuit remotely from any of these. The frequency dependence of inductance values gives rise to other constraints on this type of bridge. The calibration frequency must be well below the lesser of the self-resonance frequency of the inductor, and the self-resonance frequency of the capacitor Fr is less than minimum of L surface, C surface by 10. Before those limits are approached, the ESR of the capacitor will likely have significant effect and have to be explicitly modeled. For ferromagnetic core inductors, there are additional constraints. There is a minimum magnetization current required to magnetize the core of an inductor. And coming to the phasor diagram of Hayes bridge, and the advantages and disadvantages of Hayes bridge. Mainly, first coming to the advantages, it can measure inductance with high Q, that Q greater than 10. It can be used for measuring incremental inductance. Disadvantages: it cannot measure inductance with low Q, that is Q less than 10. The unknown value of inductance depends on loss of inductor and on operating frequency. Thank you.